What if I told you a fridge magnet, 5 centimeters long, weighing just 20 grams, is dozens of orders of magnitude more powerful than the entire Earth? It can effortlessly lift a metal paperclip off a table, beating the gravitational pull of a planet that weighs close to 6 septillion kilograms. 6 septillion. That is a 6 followed by 24 zeros. And a 20-gram souvenir wins. Now consider this. Electromagnetism, the force powering that fridge magnet, is 10,000 billion times stronger than gravity. That is not a rough estimate. That is the measured ratio. 01 followed by 40 zeros. The strong nuclear force, which holds the nucleus of every atom together, is 100 times stronger than even electromagnetism. Gravity is not just the weakest force. It is not even in the same conversation as the others. And yet gravity is the force that built every star, every planet, every galaxy in the observable universe. It is arguably the reason life exists at all. To understand how that is possible, you have to understand what gravity is up against. There are 4 fundamental forces in the universe. Everything that has ever happened, every explosion, every heartbeat, every atom holding together comes down to one of these 4. The strongest is the strong nuclear force. It operates inside the nucleus of every atom together, binding protons and neutrons at distances smaller than a millionth of a centimeter. Protons are positively charged and naturally repel each other with enormous force. The strong force overpowers that repulsion completely. Without it, every nucleus in existence would instantly fly apart. Every atom in your body would dissolve. The strong force is so powerful that it makes electromagnetism look ordinary. Electromagnetism is the second force. It governs light, electricity, magnetism, chemistry, and every physical sensation you have ever experienced. When you touch a table, you're not actually touching it. The electrons on the surface of your fingertips are repelling the electrons on the surface of the table through electromagnetism. Every sense you have, every chemical reaction in your body, every thought firing in your brain right now is electromagnetism. The third force is the weak nuclear force. It governs radioactive decay and drives the nuclear reactions inside the sun. Without it, the sun could not fuse hydrogen into helium. It goes out, the solar system goes dark. And then there is gravity. Dead last, by a margin that does not fit in the human brain. To make the gap concrete, if you took the gravitational pull between 2 protons and compared it to the electromagnetic force between those same 2 protons, gravity is about 1, followed by 36 zeros times weaker. It is so small that in every calculation involving subatomic particles, physicists simply ignore gravity entirely. And the answers are still correct. Gravity is so weak that it does not matter at the scale of atoms. So how is it the dominant force in the universe? Here's the key. Electromagnetism comes in 2 flavors, positive and negative. Opposite charges attract, like charges repel. In larger objects like planets or stars, the positive and negative charges are almost perfectly balanced. Every proton's pull is canceled by a nearby electron's push. At cosmic scales, electromagnetism effectively disappears. It cancels itself out. Gravity has no such cancellation. There is no negative mass. Gravity only pulls, it never pushes. Every gram of mass adds to the pull. Nothing subtracts from it. Add enough mass together, and even the most embarrassingly weak force in existence becomes impossible to escape. You can actually feel this yourself right now. If you're sitting down, stand up. Every muscle firing in your legs is using electromagnetic force to push against gravity. And it wins easily in about a second. Your legs weigh maybe 15 kilograms. The Earth weighs 6 septillion kilograms. The electromagnetic force in your leg muscles overpowers a combined gravitational pull of every kilogram of that planet without any real effort. You do it dozens of times a day without thinking. Every time you climb a stair, jump, or even lift a finger, electromagnetism is casually defeating the gravity of an entire planet. The only reason gravity ever wins is if you stop fighting back. That is how gravity built the universe. About 13.8 billion years ago, after the Big Bang, the universe was an almost perfectly uniform cloud of hydrogen and helium gas. Almost uniform, but not quite. There were tiny fluctuations in density, regions slightly denser than the average. The differences were minuscule. If the early universe were scaled to the size of Earth, those density variations would be smaller than the height of a blade of grass. Gravity found them anyway. Denser regions pulled surrounding gas toward them. As more mass gathered, the gravitational pull increased. More mass fell in, the pull got stronger. This is a runaway process. Over hundreds of millions of years, those microscopic fluctuations collapsed under their own gravity into the first stars. The temperatures and pressures inside those collapsing clouds eventually became so extreme that hydrogen nuclei began fusing together. Nuclear fusion. The strong nuclear force, the most powerful force in the universe, ignited, and the first stars began to burn. Gravity lit the match. Those early stars burned for millions of years and then exploded as supernova, scattering heavier elements across space. Carbon, oxygen, iron, nitrogen, the raw ingredients of planets and of life. Gravity pulled those remnants together into new stars, new solar systems, new planets, including this one. Every atom of carbon in your body was forged inside a star and delivered to Earth by gravity. But here's where it gets stranger. Gravity being this weak is not just a curiosity. It is a requirement for life to exist. Every star in the universe is a standoff between two forces. Gravity tries to collapse it inward. The outward pressure from nuclear fusion pushes back. If gravity were significantly stronger, that balance would shift. Stars would burn through their fuel in thousands of years instead of billions. Life on Earth took about 4 billion years to evolve from single-celled organisms to complex animals. A star with stronger gravity would have burned out long before that. Physicists have calculated that the ratio gravity strength to electromagnetism needs to be fine-tuned to roughly 1 part in 10 to the power of 35 for stars like our sun to exist and shine long enough for life to develop. Adjust that ratio even slightly, and you've got a universe full of black holes, or a universe where no stars form at all. The extreme weakness of gravity is not just a flaw in the universe and is one of the conditions that makes the universe livable. And yet physicists have no explanation for why gravity is this weak. This is not a gap in a textbook waiting to be filled. It is one of the most serious unsolved problems in all of physics, and it has a name. The hierarchy problem. The question of why gravity is so absurdly weaker than the other forces is something physicists have spent decades trying to answer. None of the leading theories have been confirmed. One proposal is that gravity is not actually weak. It only appears weak because it leaks into extra dimensions we can't see or measure. The other 3 forces are confined to our observable universe. Gravity bleeds out into a larger space, thinning itself out. What we experience is only a fraction of its total strength. This idea, proposed in 1998 by 3 physicists at Stanford, is mathematically serious. But there is no experimental confirmation. The Large Hadron Collider, the largest and most powerful particle accelerator ever built, was partly designed to look for evidence of extra dimensions. It found nothing relevant on this front. And the energy required to actually test where gravity might unite with the other forces would require a machine roughly a quintillion times more powerful than the collider we already have. We are nowhere near being able to build that. So here is where physics actually stands. We can predict the behavior of an electron to 10 decimal places. We have mapped the cosmic microwave background radiation left over from the Big Bang. We have detected gravitational waves from black holes colliding a billion light years away. But ask a physicist why a fridge magnet can beat the gravitational pull of the entire Earth. And the honest answer is, we do not know. Gravity built the universe, lights every star, holds every orbit in place, and made life possible. And we still can't explain why it's so extraordinarily, almost comically weak.